Good afternoon. My name is Ronak Ansari. I am from District Anupur, Madhya Pradesh. Currently, I am pursuing Integrated MTech from Vellore Institute of Technology, Bhopal. So, our topic is Mathematics PowerPoint presentation trigonometry. Now, I am going to explain what is trigonometry. So, basically, trigonometry is a very basic branch or very important branch of mathematics that makes the relationship between the angles of triangles and involving lengths. And this trigonometry came in the 3rd of century. Now comes to the history of the trigonometry. So the basic history of the trigonometrics means the trigonometry start from the Hipparchus astronomers, that is came 190 to 120 bits of century, and in order to Aryabhats in came 476 to 550 century, and in this century the Aryabhats found the zero and put the base of zero. Now one important point is that Albert Gigard is a very great French mathematician that found the cos and sine and tan thetas of the abbreviation. So now comes to the third slide, that is trigonometric functions. So you can see that in the image r is a hypotenuse, y is a perpendicular, and x is a base and theta is a angles. So there is a basically three trigonometric functions. There is a three common trigonometric function, that is sine, cos, tan. And what is the value of sine? Sine is equal to perpendicular upon hypotenuse, that is y upon r. Cos is a base upon hypotenuse, that is x upon r. And tan is equal to perpendicular upon base, that is y upon x. And you don't need to remember cosec, sec and cot formula, because it is the opposite of sine, cos and tan respectively. Okay, now comes to the example. So in the question we have a value of tan a is equal to 4 upon 3. We know that the value of tan a is equal to perpendicular upon base. So you can see that in the image perpendicular is a BC, that value a, so the value of a is equal to 4, and the base is AC, and the value of AC is B, and the base of B is equal to 3 according to the questions. So now comes to the find the rest of the functions. So you can see that in the image we don't know the value of C. So how to find? According to the Pythagoras theorem, we know the value of AC square is equal to AB square plus BC square. So you can see that we know the value of AC. We need to find the value of C, that is AB. So now put the value and we get 5 centimeter is a hypotenuse. Now comes to the value of sine A. Sine A is equal to perpendicular upon hypotenuse. So perpendicular is a BC and hypotenuse is a AC. In this image C is missing. C is a place of B, should be C is place of B and B is place of C. So there is a mistake, one mistake. Now comes to the sine A is equal to BC upon AC. The value of BC is equal to 4 and the value of AC is equal to 5. Now you don't need to find the value of cot A, because you know that the value of cot A is equal to opposite of tan A. Okay, and respectively you can find rest of the values. Okay, so comes to the trigonometry values of some angles. So there are 5 angles at 0 degree, at 30 degree, and at 45 degree, at 60 degree, at 90 degree. So you need to remember only 3 value: sin theta, cos theta, tan theta at some different values. And you don't need to remember cot theta, sec theta, cosec theta's values, because you know that this is the cot theta, sec theta, cosec theta is the opposite of sin theta, cos theta and tan theta respectively. Okay, now comes to the some important formulas, that is sin square theta plus cos square theta is equal to 1 plus tan square theta is equal to sec square theta, and third is 1 plus cot square theta is equal to cosec square theta. Okay, now comes to the example. So what is the question? Question is that tan x into sin x plus cos x is equal to sec x. We need to prove. So we can take the LHS, that is tan x sin x plus cos x, and we know the value of the tan x sin x upon cos x into sin x plus cos x, and sin x into sin x is multiplied and we get sin square x upon cos x plus cos x. Okay, so sin square x upon upon cos x plus cos square upon cos x. So we need to into here cos x and divide cos x, so rest of the values similar as well as cos x. So we can take the LHS, we can take the LCM of cos x and we get upper of sin square x plus cos square x. We know the value of the cos square x plus sin square x, that is 1 upon cos x, and we know the opposite of the cos x, that is sec x. So we the sec is, that question is proved. LHS is equal to RHS. Okay, this is the some important formula, means sin theta minus 90 minus theta cos theta, you need to remember. Now comes to the application of the trigonometry. So you can see that we observe generally when the airplane it passes overhead, so this line joining our eye to the plane while looking up is called line of sight. So there are lots of application in different fields. So now comes to the conclusion part. So what is the conclusion part? So basically we can say that the trigonometry is a very basic or very important branch of the mathematics, and there are lots of application in our daily life, as well as there are lots of different fields for use trigonometry. So and there are lots of several searches are going on the topic of trigonometry. So I suggest you please remember formula, because it is easy for solve the trigonometry problems, and need to carefully study trigonometry because this is very important for your future work. That's it from my side. Thank you.